Hi, in this episode, we'll be doing Form 5 Chapter 5 Electronics State Paper for 2024. Let's start. Okay, so we start with Percubaan Negeri Pahang. We will start with all the cathode ray first, then we will go into diode. Now, if you are here for transistors, I have a separate video specifically to talk about transistors, which I'll link in the description below. Okay, so guys, let's have a look. Okay, so what is the characteristics of cathode ray? So actually, what is a cathode ray? A cathode ray is actually an electron beam. So you just have to remember, cathode is electron beam. So usually, I will just say that it is negatively charged. Okay, because it is also a beam of electron, you are allowed to write it has high velocity, high kinetic energy also okay, but I think negatively charged is the easiest. Okay, explain the process of how cathode ray is being produced. So usually there is heat being applied to this cathode, which will cause the electrons to be emitted. Now you must remember what is the name of the term when your electron is being emitted. So think, what is the name of this process? The name of this process is called thermionic emission. So please do remember this thing. Okay, so let's have a look here. Name the process. So we will say as the cathode is being heated, then we will say thermionic emission will occur. So if I say thermionic emission, then that means that the electrons are being released from the surface of the metal due to the heat. Okay, then next, so now your electrons already released. How will your electrons know that they have to move all the way to the anode? So this is where we will say that there will be a high voltage power supply. EHT actually stands for extreme high tension, but we will just say high power supply. Then we will say that a high voltage is being supplied to the anode, or you can say across the anode and cathode. Okay, so therefore this will cause, so if you have a positive voltage here, so therefore your electrons is negative, it will be pulled towards the positive plate. But rather than you just write pull is a very lousy word, we can say that this will cause the electrons to be accelerated to the anode to form your cathode rays. So when they accelerate across to the other side, then it will gain kinetic energy. Okay, so it's a very simple statement, but it's also 3 marks. So it's a very easy statement. You talk about how your electrons are being made, then you talk about what do you put. You need the high voltage. If no high voltage, right, if there's no positive here, these electrons will not be attracted to the right hand side. Okay, so now it will be accelerate to form the cathode rays. Okay, now there's a calculation here. So they will say that it accelerates from cathode to anode. The potential difference is this much. Then they want you to calculate electrical potential energy and the maximum velocity. So in this subtopic, you have to understand that when your electrons are being accelerated, they are using this thing called the electrical potential energy. How to calculate it is EV. Sometimes you will see QV. Q is charge. But why do we use E? Because E is the charge of the electron. Of course, if you accelerate your electron, you are going to get kinetic energy. So EV equals to half mv squared. So therefore, this is what you get on the right hand side. So which is your kinetic energy? So let's calculate the electrical potential energy first. So you have the charge of an electron, not the mass, guys. Don't take the wrong information. So you have this 1.6 times 10 to the power of negative 19 and then the voltage is 670 volt. So we will multiply by 670, it will be 1.072 times 10 to the power of 16. What you need? Because this is electrical potential energy, so this is measured in terms of joules. Next, what about the maximum velocity of the electron when it reaches the anode? So if you want to know that this is going to be equals to your kinetic energy, EV is equals to half mv square. So what you will know that this is straight away 1.02 times 10 to the power of negative 16 equals to half mass of your electron is given 9.11. So guys, you can take your book and do along with me. So that now you have this answer, multiply, divide, and square roots. You will realize that your velocity will be 1.534 times 10 to the power of 7 meter per second. Okay guys, so this question total is actually 9 marks. It's a big question, but it's very easy. It's related to cathode ray. Okay, how can a cathode ray question be more complicated? How can it be more complicated? So this is an essay from MRSM. Okay, for cathode ray, you will see the first thing that they ask, what is the thermionic emission? So it is a process of release of electrons from heated metal surface. Guys, every word here is very important. Surface, metal, heated, release electron is a process. So therefore, this is how you get this one simple mark. Okay, then they will ask you, so given that is this, given that this, then they say if this is 5 kilovolt, can you tell me the kinetic energy of the electron? So guys, if you do this and you write half mv squared, you will have a trouble. Why? Because you do not have the velocity. So how to find kinetic energy macam ni? Okay, never mind. You need to know, right, that EV is equals to half mv squared. So guys, I see people memorize all the very fancy formula, what 2 EV over m. But you see, right, in the question, usually they don't immediately call you to find velocity. They want you to find the kinetic energy. They want to find the electrical potential energy. So it requires you to have a bit of understanding that your EV is your half mv squared. Okay, your E is going to be 1.6 times 10 to the power of negative 19. So that's your charge. So we will use EV to calculate the kinetic energy. So this is 5,000 watt. So if I take 1.6 times 10 to the power of negative 19 times 5,000 watt, I will get 8 times 10 to the power of negative 16 joules. Once I have this, to find the maximum velocity. Okay, so remember this is your EV. Your EV is actually your half mv square. Can so means you cannot find half mv square, you find EV because the answer is the same. Now I got EV ready. So what can I do? I can use this EV, which is 8 times 10 to the power negative 16 equals to half mv square. Look familiar? It was the same calculation as just now. So 8 times 10 to the power 16, half m, m is what? Is your 9.11 times 10 to the power of negative 31 velocity square. So you will be able to calculate your velocity by just pressing into the calculator. So 10 to the power of 7 meter per second. So it's a very simple question on cathode ray. Okay. However, the most annoying thing about cathode ray is when they ask you there is a Maltese cross tube. Okay, rule number 1, guys, check. Okay, let me give you the idea. Why is there 2 different voltage on your Maltese cross tube? Okay, because for the first one, this one produces light. okay? So the second one is to produce the electron beam, which is the proper term for it is called cathode rays lah. So you need this EHD, the high voltage, to accelerate the electron, okay? So if you have 6 volt only, you only get light. If you have switch S1 and S2 are closed, then what will you have? You will have both the light and the cathode ray. Okay, so what will we observe on the fluorescent screen? Okay, number one, if you take light and you shine on a object, so this is an object that will block light, so you will form a shadow. So light will produce a shadow, but of course, if your cathode ray, right, if kena block, so imagine the cathode ray move, then suddenly you block the cathode ray. So what will happen at the back? You also get another shadow. Okay, the only difference here is that light can be like white light, yellow light like that, right? Cathode ray form punya light, the light ray that's formed by a cathode ray is usually fluorescent green. Okay, so we can say a green shadow is formed, a fluorescent green shadow is formed. So the first statement I will say before even I start writing, I will say two shadows will be formed on the screen. Okay, so the first one we will say it's the first shadow is due to light being blocked by the Maltese cross tube. Okay, so the first shadow. In exam, probably you want to write FIRST. Okay, then next. What about the second shadow? So we will say that the second shadow is formed when cathode ray is being blocked by the Maltese cross tube. Okay, so I say light block, you get one. Then after that, you have second shadow is because your cathode ray get blocked. Okay, then finally the last one. So we have to explain why your cathode ray being blocked will form a shadow. So we can say that your second shadow is formed as cathode ray collides with the fluorescent screen as its kinetic energy changes to light energy. So what happens here is that when your kinetic energy changes into light energy, then you actually form the second shadow. Alright guys, I apologize about the handwriting a bit ugly lah. Okay, so therefore this is on the cathode Maltese cross tube. There is one more thing that you can read, which is what happens if I put magnetic field to the Maltese cross tube. The shadow will move, but the cathode ray will move, but the light will remain the same place. Okay, why? Because your electrons is affected by magnetic field. So that one you can go and see yourself. For second part of this video, I want you all to have a look at a diode, specifically semiconductor diode. Okay, what is semiconductor diode? So there are complex process of there's a reason why you have p-type and n-type, but most importantly, you have to know a semiconductor diode, it will basically just allow current to flow, okay, basically to flow in one direction only, in one direction only. So your current is only allowed to flow from P to N, boleh, but when you want to go from N to P, tak boleh. Okay, why? Let's just quickly do this, a bit of a recap. Okay, so when you see you have a PN type, you will realize that if this is a battery with a wire, when your positive is connected to positive, this positive will push this positive, this negative will push this negative, so causing your P to N to be squeezed together. So when they squeeze together, it will be able to conduct electricity. Okay, you just imagine there is a place here, and then there's a place here, and then in the middle got river. Okay, so if these two wall starts to move closer, the river becomes smaller, so the thing can move across. If the other way around, if this one becomes bigger, now your river become bigger, means that your current is even harder to flow. So solution is what? Very simple one, guys. Okay, how to see if it's bigger river? It's very easy to see one. So you see, if now this is positive, this is negative. Okay, you tengok this is negative. So negative will actually pull this positive to this side. And then which your right hand side here positive now, this negative kena pull to this side. So now these two things is going to be pulled further apart, causing the river in the middle to be bigger. So if now in the middle got a very big gap, can conduct electricity or not? Of course cannot lah. So now what is the name of this river? So we call this as the depletion layer, also known as sometimes they call it depletion layer. In BM we call it as lapisan susutan. Okay, what's next? So you have a diode which will be connected in this way, and then you have this wave. Okay, why? So we will say that there are two cycles in your alternating current. Rather than calling them positive cycle and negative cycle, let's just call this the first cycle and the second cycle. So first is going up, second is going down. First cycle and the second cycle. Okay, so when you transform diode, which is PN, into a schematic drawing, means that you draw in a symbol form, it's even easier to see. Why? Because you have to follow the arrow only. See, this arrow is actually pointing towards the right hand side, right? So meaning to say that your red color can flow. Okay, so your red color can flow across it, your red color can go all the way back. So that's why your number 1 can flow. Okay, number 2 can flow or not? So when the number 2 goes the other way around, you will realize that here there's a wall, kena block already. So number 2 is being blocked. Okay, so generally we call this as a half wave rectification, because when you use red color, boleh follow the same arrow, follow this arrow direction, okay, as you can see. But when you try to go through the green color, it will hit the wall. If it hits the wall, means it stops it from flowing, so cannot flow langsung lah. So that's why you see the bottom part of the wave, the green color all here already been cut off. You are only left with the first half cycle, green color punya cycle, all hilang already. Okay, now so explain why the wave pattern displayed as shown in 8.3. Okay, so how are we gonna explain this thing? We can say during the positive half cycle. Okay, so this is where they test your terms. Okay, we will say that the semiconductor diode is in forward biased. Okay, so forward bias is a term known for when your current can flow, means you allow the current to flow. So we will call that as forward biased. Okay, then therefore your current can flow across the circuit. Okay, now however we have to say the other way around. So your first half cycle, positive half cycle, is the first one. Okay, now what about the green one? For the green one, we just give it another name. We will say during the negative half cycle. Now is the negative half cycle pula. Okay, so what will happen? Then we use back the same thing. We say our semiconductor is in, guys, what's the opposite of forward bias? So it is in reversed biased. So therefore your current cannot flow. That's why you will have no current flow. Okay, so this is a very important way that they try to use all these terms. So guys, remember, you need to be good in terms, especially for Form 5 chapters. I repeat, Form 5 chapters terms very important. Okay, then after that, now they gave you a transformer and a diode. So this is like a structured question. Okay, so like a structured mini essay question. So what is the number of diode used? What is the transformer? And what is the additional component? Okay, so if you see here, this is called half wave rectification because you only put one diode and therefore you only get half the wave. The green color wave is being wasted, is being thrown away. You only get half, the bottom all hilang already. So if we want to obtain full wave rectification, how many diodes do we need? So generally we need 4 diodes. Okay, how do we connect it? Later I show you in an essay question. Okay, now this is a smartphone you want to charge. Okay, as you can see, if you want to charge a smartphone, usually it is decrease in voltage. So this will be known as a step down transformer, whereby what you do here is you want to reduce the voltage. Did they give you the initial value? Let me see. Tada, tabagi langsung. To reduce the voltage, to charge the phone. Okay, so therefore that's it. Definitely it's a step down transformer because no known charger, no charger that I thought uses more than 240 volts. Okay, now lastly we have to do something called the smoothing. So therefore we will add capacitor in parallel. Okay, so sometimes, right, some teachers, if you say you add capacitor, they say add where? Add in front, add series, add parallel, add side by side. So we say add parallel to the circuit or to the charger. Okay, so what's the reason? To allow smoothing of output current. Okay, so right now you have 2 main thing that you question mark in your brain. What is a capacitor? Why do you need to do smoothing? And what is actually full wave rectification? Guys, very simple. Okay, you can just have a look at the essay question on page 5. Okay, so if you see here, this is a full wave rectification, this is a full wave rectification. And what is smoothing? Smoothing is when your output circuit looks like this. Okay, so when you smooth it, your current will not be wave like that. It will not go 1, 2, 3, 4. Because the disadvantage of this is your current will sampai 0, which means that your current will suddenly increase, then stop, then increase, then stop, then increase, then stop. So it is not what we want. We want the current to not drop to 0. So you can see, right, if I put the 0 line here, you see that my current will, it will fluctuate a bit, it will increase, decrease a bit, but at least it doesn't go to 0. So the whole purpose of this, right, is we need to know that if you want to charge the smartphone, you need to change this alternating current to direct current. So one more thing, just in case if they ask you, do you put transformer first or diode first? So obviously, okay guys, remember, so your input of your 240 volts. Remember, it is always transformer first, baru go into your diode, baru you do charge. Why? Because you need alternating current for the transformer, then only you change this alternating current come out from the transformer, then only direct current to the charger. If you write diode in front of transformer, maybe you'll get it wrong. Okay, Ken? Just in case if they ask you the sequence, it's transformer first, then diode, not diode first, then transformer. Penting or not? Very penting. Okay? Now, so you will see that for this one, our answer will most likely be this one. So typical charger is step-down transformer. Full wave rectification allow smoothing. This is full wave rectification. So if you want the answers, you can refer to the back part of it. Okay, so I can show you the answers are provided at the back. So this is on the diode part. One bonus question to do together. Okay, so let's see. So what is the function? Okay, so this is the Penang set 2. What is the function of semiconductor diode? So it can change alternating current to direct current. Okay, rather than we say they change only, by allowing current to flow in one direction only, to flow in one direction only. Okay, can Now, so what will happen when the bulb is closed? Okay, guys. So when the switch is closed, not bulb is closed. So what will happen? Okay, so can flow or not? If you see here, zoom. Do you see that the arrow is pointing in the opposite direction? So therefore, this cannot flow. Why? Because it is called reverse bias. So the answer is that the bulb will not light up. It will not light up. Okay, so give a reason for your answer. Then you just have to say why? Because your semiconductor diode is in reverse biased. It's connected in reverse bias. So means you block the current, cannot flow. Okay, now we go and see when you put this one versus if you change it to alternating current, because this is dry cell. So like I said, since kena block this one, your current confirm kosong, cannot flow, no current flow at all. What about alternating current? Interesting, because only one diode, so therefore only half of the wave will flow. So you can draw either the positive wave or the negative wave, guys, it doesn't matter. So let's say I draw like this, then here flat, then I draw one like this, then I draw flat, then I draw one like this, then I draw flat, that's it. Okay, so means I only have half wave rectification. Guys, you all draw nicely lah, okay, in exam. Okay, so therefore that's it, half wave rectification. If you draw the positive, only no negative, also okay, also can. So name the process involved. Okay, this we must write that it is called half wave rectification. So rectification is the name of the process of changing the alternating current to direct current. Okay, so in this short video, we are able to do CRO, cathode ray, and also diode questions. So if you need to finish up the other question, you can refer to the answer at the back. For transistors, you can refer to another video, which is the revision trial series. So thank you everyone. See you guys again.